Hello, this is Randy. Today we'll learn how to determine the sign of a polynomial within a given interval. Let's go. So in this first example, we are asked what is the sign of the following polynomial. Here's that polynomial that it's talking about, between the x values of -9 and -5. So you'll notice that I drew a graph, which is the graph of this function right here. And we're going to talk about what this looks like graphically first, but eventually we're going to learn how to solve a problem just like this without using a graph. So before we learn how to solve this algebraically, let's look at the graphical representation of this function. So you'll notice that the function is x plus 9 times x plus 5. We could multiply those out, but we don't need to right now. So let's look at where are the zeros. Well, we have one zero, that is x-intercept at x equals -9, and another zero at x equals -5. So let's try to answer this question just looking at the graph. So they say, what is the sign that is positive or negative of the polynomial between the x values of -9 and -5? Okay, well, where is our polynomial between x equals -9 and x equals -5? Well, starting at x equals -9 and then going right, all this is the polynomial. So now what is the sign of that portion of the graph? Well, when they ask that, they're asking what is the sign of the y values of that portion. So you can see that the y-axis is the vertical axis, obviously. So is this portion of the graph in the positive or negative on the y-axis? Obviously negative, right? Because we're below the x-axis, so we're negative on the y-axis. So without doing any algebra, we can see that the answer is negative. That is, the sign of the polynomial is negative in that interval. But let's figure out how to get this same answer without using the graph, because we need to know how to do this algebraically with no graph. So let's start from the beginning again, now that we have no graph. So my advice when you see a question like this is, first of all, just figure out where are the zeros of this polynomial. So in order to find these zeros, I just took this factor, x plus 9, and set it equal to 0, and then solved for x, and I got -9. And then I set this factor equal to 0, and then solved for x, and I got x equals -5. If that part, finding the zeros, felt strange to you, I would encourage you to watch our video on finding the zeros of polynomials. So pretty soon you'll see why it is important and helpful to know what are the zeros of the polynomial. So next, I would encourage you to just draw a number line and then graph these 2 points on the number line. And a simple number line just like this is good enough. So now that we have our number line, let's figure out where is the interval that they're asking about in relationship to our zeros. So you can see that that interval is exactly between our two zeros. Now we just need to figure out, is our graph positive or negative in this interval? How do we do that? Well, the easiest way is just to plug in some point that is between -9 and -5. So we could plug in -8.5, we could plug in -8, we could plug in -7, right? We could plug in -6. Any number in between these 2 points on the number line, we could plug in for x right here and right here. So I think it'd be pretty easy to just plug in -6 because -6 falls in that interval. So we're going to plug in -6 for x right there, and then we'll simplify the entire expression and see if that number is positive or negative. Okay, so -6 plus 9 will give us a +3. And then we have that number, +3, times -6 plus 5 is -1. So is -3 positive or negative? Obviously it's negative. So that sign on our final simplification, that negative, tells us that our answer is negative. So now we have the same answer that we had before, but we used algebra to find it. So that is the process that we need to use in order to find the sign of the polynomial if we have only two zeros that are also, listen closely, the start and endpoints of the interval, like in this case. if we have a polynomial with a 0 that is not the start or end point of the interval, that is, somewhere within the interval, things get a little bit more interesting. So they say, what is the sign of the following polynomial? Here's the graph, and here's the function, between the x values of -2 and 3. So real quick, we'll find the answer using the graph, and then we'll talk about how to get that same answer without using the graph. So in this case, we have 3 x-intercepts, or 3 zeros, and those zeros are at x equals -2, x equals 0, and x equals 3. Now, where is the interval that they're asking about? That is, where is -2 and 3? Okay, well, -2 is right here, and 3 is right here. So let's trace that entire interval on the graph. So that entire black part is the part of the graph that they're asking about. So is the y value or the y values in this part of the graph negative or positive? Well, both, right? Because in this first part, before we hit x equals 0, you can see that that black part of the graph is positive, right? It's above the x-axis. And in the second part, after we pass x equals 0, this part is negative. So what's the answer? The sign of the polynomial in the interval that they're asking about is both positive and negative. Here's the positive, and here's the negative. So the answer could be both. All right, so there's our answer, both positive and negative. Now let's try to get this answer without using the graph. So first of all, let's find our zeros, and then we'll plot those zeros on a number line to kind of get a better idea of what we're looking at. So by setting each factor equal to 0, we get that the zeros are x equals 3, x equals 0, and x equals -2. And there's our number line. Now we have our zeros at -2, 0, and 3. Next question is, where is the interval that they're asking about in relationship to our zeros? This is a very important question. So our interval covers this entire span of x values, from -2 all the way to +3. Now, in a future video, we'll talk about something called multiplicity, okay? But in this video, we are not going to talk about multiplicity, which means that whenever we have a 0, our graph crosses the x-axis. Why is that important? We know that the graph will cross the x-axis, and the sign will be both negative and positive because we know that it crosses at this point right here from positive to negative, or from negative to positive. Even though we've already looked at it, the graph could look like this, something like that, or it could look something like this. And for this topic, the point is that this interval contains both negative and positive y values. Now, really quick, let's say that we had this same function, but the interval was different. The answer could be just negative or just positive. So if we had an interval, let's say from 0 to 3, instead of -2 to 3, what would be the sign? Well, now this becomes like our first example. We just need to test a point that's in this interval. So we'll just test 1. That sounds pretty easy. Notice that if we have more than 2 zeros in the interval, that we didn't even need to test a point. But now we have just 2 zeros in this interval, 0 and 3. So we're going to test 1 for x here, here, and here, and then decide what is the sign of that simplified expression. So when we plug in 1 and we simplify, we get -6. So if the interval were between 0 and 3 instead of -2 and 3, then our answer would be negative. But we know that the original question was, what's the sign between -2 and +3? So our answer is both positive and negative. So if our interval starts and ends at zeros and there are no zeros in between, we know that we can just plug in some number in that interval and figure out the sign. And if we have some 0 within the interval, much like in this case, we know that the graph will cross the x-axis and our answer will be both negative and positive. And with that, we are finished.